Hi guys, today we have one team going to the local school. We are changing some breakers that the PA wanted us to change, so we're gonna do that today. And then we have the black car is going on repair, so we're gonna organize equipment here. One thing that I wanted to talk about for actually a long time, I just haven't had time, is battery quality and what's the difference between low quality lithium batteries and high quality lithium batteries. One difference is the chemistry. You know, you have the NMC, and sort of now they call it the old type, but it's not really that old, because even in the Powerwall, the Tesla, NMC was used in Tesla Powerwall 1 and 2. It's only now that they moved to LFP. LFP is what we use, you know. LFP is the safe battery type and good battery type. NMC actually, and they had to recall some NMC batteries from the market because, well, they're dangerous basically. And that's one risk with buying low quality lithium batteries, obviously, that if they do something wrong, it can be extra dangerous and they have to do recall. So, and with LFP, things like that is less risky, less problems, and so everybody's moving to LFP now. So that's one element of good quality batteries, is the chemistry itself. Another is the separator between the plus and minus side inside the cells. So on high quality batteries, that separator is it's thinner than on lower quality batteries. Why is that? It's more expensive to make a separator that's thin. It's just more technologically difficult to make it thin. But another thing is that the reason why they want to make it thin is because then when you have a rapid discharge, a high discharge, the electrons want to move fast. So then if you have a thick separator, you're going to have a lot more heat. And heat is what damages batteries and makes the lifetime of the batteries shorter. So when you have a thick separator, it creates problems when you have high level discharge, fast discharge. So that means that if you have low quality batteries and you discharge a lot when you use the batteries, the lifetime going to be quite a lot shorter. Now, how much is difficult for me to answer because I'm not working on battery development. It's very difficult to quantify, but that those things are relevant, there's no doubt. So to summarize, heat deteriorates batteries, and heat is produced especially when the separator is thick, which is the case on lower quality batteries, and when you have a high discharge. So there's a combination there that can be quite bad. But when you talk about batteries like Alpha that we install, then the separator is thinner, so the heat production is much less. And that's also why the ratings of those batteries, that they can push 10,000 watts at the same time, and that they last, 8 or 10,000 cycles, depending on which model that you look at. And then another factor is the volt. Most manufacturers make 48 volt batteries, but the problem with those is that when you use them in residences, you have to convert, and then you lose a lot of power. But they don't talk about that. But that is why the high voltage batteries that we have works much more efficiently, and less loss and less work for the system to convert. Like for the Smile 5 G3, it's 96 volt, and for the T10 and T20, the three-phase, it's 256 volt. So that's another thing that you have to look at the voltage. You're going to have a huge loss if you have low voltage batteries. So you can ask yourself, why do they even make them? Well, it's just because of sales. Because when you make batteries, you're thinking, which inverters can use the batteries that I want to make? And the more inverters can use them, the better it is for you as a battery manufacturer. It's not better for the consumer, but there are so many inverters on the market already that's using 48 volt. So that's why they continue like that. So that's just a few factors that you should consider when we talk about batteries, and there's a lot more that I will get into later. So I just wanted to give you a little bit of information about high quality versus low quality LFP and NMC batteries.